Welcome to your Grade 12 Momentum and Impulse past paper series. Today, the first past paper series, we're looking at this paper from Navy's Eastern Cape that was written in September 2023. So let's read this. It says, it says 2 trolleys, A of mass 1 kilograms and B of mass 2 kilograms are held stationary. So I'm already getting that initial velocity is 0. Do you guys see that? Initial velocity is 0. Right? Initial velocity is 0 meters per second. Are held stationary on a smooth horizontal surface with a compressed spring between them, as shown in the diagram below. The spring is released and falls to the ground. Trolley A moves to the right. Oh, I should also note this. Mass of A is 1 kilogram. Mass of B is 2 kilograms. Then the spring is released and falls to the ground. Trolley A moves to the right at a constant velocity of 5 meters per second. So velocity final of A is 5 meters per second way to the right, okay, to the right, and collides with a wall. Assume this is an isolated system. Oh, interesting. Number one, we must define what is an isolated system. Now, what is an isolated system? It is a system in which the resultant force is 0. We have shown in the videos when we were introducing the concept. System in which the resultant force is 0. Alright? System in which the resultant force is 0. Right? Perfect. Number 2, it says we must now calculate the velocity of trolley B immediately after the spring is released. So, momentum calculations, as we have been saying, is a vector calculation. So I will take the right as positive. So I will say right is positive. Okay. So going to the right is positive. Okay. So we have, remember they were stuck with the initial velocity 0. So I can consider them to be a unit. So that conservation of momentum theory formula, I can reduce it to this. Mass of object A plus mass of object B, all multiplied by initial velocity, is equal to mass of object A multiplied by velocity of object B final, object A final, plus mass of object B multiplied by velocity of object B final. So object A was 1 kilograms, 1 kilogram. Object B was 2 kilograms. Initial velocity was 0. Now, object A is 1 kilogram. Final velocity of object B is 5 meters per second to the right, so it will be positive 5. We said the mass of object B is 2. Final velocity we do not know. So this is 0 equals 5 plus 2 VBF. Okay, 2 VBF. Proceeding, we will say velocity, or 2 times velocity of object B final is equal to negative 5. Is it okay? Yeah, it's okay. It doesn't matter. It's okay. Perhaps if one is confused because I should move this, it's okay. Let me just do this. So it will be VB of F is equal to negative 5 divided by 2 will be 2.5. It will be negative 2.5. Therefore, the final velocity of object B, or velocity of object B after the spring is released, is 2.50 meters per second. As you can see, this value is negative. Therefore, it means it's going to. Now, let's look at question 3. We're done with this. It's okay. It makes sense. Question 3 says, calculate, let's see. Oh, it says the average force exerted by the wall on A is 80 newtons. So note, force exerted by the wall, okay, is 80 newtons. Be careful. It's 80 newtons. It's 80 newtons. Where does it? The wall, when you look at it, the wall basically will apply a force to the left. So please let me say left. Okay, perfect. And the collision of the trolley with the wall lasts 0.5 seconds. So the delta T is 0.5 seconds. Calculate the velocity with which the trolley A moves away from the wall. Okay, so note something. We said going to the right is positive, right? Going to the right is positive. So this is Newton's third law of motion. So the trolley A, what it does is that its force will be negative, right? It will be negative because according to Newton's third law of motion, the forces will be the same but in opposite direction. So force of, oh sorry, I should say the wall, not B. I should say the wall. I should say the wall, right? So what is the magnitude of the wall? It's 80 newtons. So it's okay. I'm going to leave it as. So the force applied by cut A or trolley A is basically negative 80 newtons. Okay. So we know the momentum impulse theorem is F net is equal to delta P over delta T, isn't it? Or simply it is F net delta T is equal to delta P. Again, what we know, because we are looking for the final velocity, let's write this guy as velocity of mass of object A times final velocity minus initial velocity. So what is the F net? We said it is negative 80. You remember, right? It is negative 80. Now what is the time taken? The time taken is 0.5 seconds. 0.5 seconds. What is the mass of object A? The mass of object A is 1 kilogram. What is the final velocity? We do not know. It is what we are looking for. What is the initial velocity? It was 5. So negative 80 times 0.5 is negative 40. 1 times V sub F is VF minus 5. Therefore, what is this? This is negative 35 equals V sub F. Therefore, the final velocity will be 35 meters per second. Where? Left. Indeed, when this trolley collides with the wall, it'll bump into the wall and bounce back, right? And bounce back. So yes, we expect the object to move back. Hence, this velocity shows that it's in the opposite direction, which is the left. Okay, perfect. All right. Now, let's see. So, next one, now being asked, a learner comments that the collision of trolley A with the wall is inelastic. Briefly explain what is meant by an inelastic collision. This does not really require you to make any calculations. It just wants a definition, okay? It only wants a definition. What is an inelastic collision? It's a collision in which only the total momentum is conserved and the total kinetic energy is not conserved. So let's write it down. Collision in which only total momentum or total linear momentum is conserved and the total kinetic energy is not conserved. and the total kinetic energy is not conserved. This is what this student means. Okay, this student means that total kinetic and total momentum is conserved, but the total kinetic energy is not conserved. This is what the student means by saying condition is inelastic. So remember, guys, when you are into your examinations, time management is also important. This question says you must spend 2, 4, 4, 12. You must spend at most 12 minutes into the question. Okay, this is so that you can have enough time to come back and fix your mistakes later, and also you can also be able to finish your examinations. Okay, so as you can see, we were able to finish this. I think it was at around 9 minutes, but right now we are on 11. It's okay. So this is it, guys, and I hope you understand this. So adios.